All right, now we're starting in Algebra 3, Section 2.5 on functions. And we're going to start talking about symmetry and whether the symmetry of a function is even or odd. A function is even if when you put in negative x for your function, so f of negative x is the same as f of x. So in other words, when you put in negative x, if it's the same as the original, when you simplify it, then it's an even function. If, however, you put in negative x for x, the result is the opposite of the original function. And what that means is that all terms are opposite, then it is an odd function. So when you plug in negative x in place of x and you simplify, if the function is the same, it's even. If all the terms are opposites, then it's odd. So we're going to try with this first one. Anywhere that there's an x, you're going to plug in negative x. Oops, negative x. So this is negative x squared plus 8. When you square negative x, two negatives make a positive, so this becomes positive x squared plus 8. That's as far as you can simplify it. And if you compare it to the original, it's exactly the same as the original. That means it is an even function, because when you plugged in negative x, you got the same result. Move that down a little bit. You get the same result as you did in the original. Okay, so let's try another one. Okay, so this next one, we're going to plug in negative x wherever there is an x. So I'm going to plug in negative x cubed minus 5 times negative x. And on this one, negative x cubed, if you have 3 negatives, that makes it negative. So this becomes negative x cubed. And this, you're not raising it to a power other than 1, so this stays the same. I'm going to multiply these two. Negative 5 times negative x is a positive 5x. And when you compare this to the original, the first term is the opposite, the second term is the opposite. Since all terms are opposite, this is an odd symmetry. So if you get the same, in other words, all the terms are the same sign, then it's even. If all the terms are opposite, then it's odd. Here, when I plug in negative x, I'm going to try another one. I have 3 times negative x squared minus 6 times negative x. Negative x squared means I'm squaring the negative, so that becomes a positive x squared. So this is 3x squared. Here I'm going to multiply negative 6 times negative x is a positive 6x. And so in this one, the first term is the same sign, but the second term changed signs. So they're not all the same, and they're not all opposite. So this one is neither even nor odd. Okay, if all the signs stay the same, it's even. If all the signs change, it's odd. If some change and some don't, then it's neither. Okay, so that's what we do with even and odd symmetry. The next thing we're going to talk about is increasing and decreasing intervals. And we're going to introduce our graphing calculator here at this point. And I'm going to start with, I'm going to show you on your graphing calculator what it should look like and some of the buttons we're going to push. And what we're going to do is we're going to enter this function. What I went to here is the y equals button. So let's see if I clear everything. And then I hit y equals. Now I'm going to put this function in. Your x is on this xt button. I'm x squared plus 8. And then what I'm going to do is hit, so first you do y equals, and then you enter the equation. Then you're going to hit the second button. That's this one. And then you're going to hit the calc which is right above trace. So you're going to hit second trace, which gets you to your calc functions. And then you're going to hit the number 3 for minimum. And this is going to give us the minimum value. So when I hit 3, it graphs the function for me. But then down here it tells me x is 0 and y is 8. So that means that my minimum is at 0, 8. And if I look at, I can kind of see from this graph that this is a quadratic function, and so it's a parabola that's above the x-axis, so it's kind of like this. And I know that the vertex of the parabola, the minimum, is at 0, 8. Next thing I'm going to talk about are the increasing and decreasing x values. So when we're talking about increasing or decreasing, you're going to use the x values. So you're going to go the domain, which is from left to right. So if I'm going from left to right, it starts heading down. And so again, remember on my x-axis, that's negative infinity and this is positive infinity. And it goes down, so it's decreasing from negative infinity, and it keeps decreasing until it hits 0. And then at 0, that's, let me change colors here, just going to kind of emphasize it a little bit. At 0, it starts going up. So it's increasing from 0 to positive infinity. Okay, so these are my increasing and decreasing intervals. That's what we're looking at. We kind of sketch the graph and look at where it goes up and where it goes down and describe where it along the x-axis, according to the x values, where does it change direction. That's what we're looking at. Okay, so let's try another one. Okay, so for this one, I'm gonna go to y equals again. I'm gonna clear the equation I had in there before. Now I'm gonna put x, maybe I should put it up here, x, use the caret for raised to the third power. Whoops. Okay, make sure that you get out of the power when you, to go on. And then that's minus 5x. Okay, so you get it into the y equals first. We're going to hit second trace, which gets us to our calculate function. And I'm going to start with the minimum. I want to see what the minimum looks like. And then notice it sketches it for us. So I'm going to sketch what I see on my graphing calculator out to the side here. And it looks like it goes up, it goes down. Oops, let's bring this down so you can see. Up, it goes down through the origin, goes down, and goes back up again. Okay, so that's the shape of this particular function. And the minimum is going to be this point here because that's the bottom of a loop. This is my minimum. And that then is going to be my maximum. And so if I'm trying to find the, I just put in the calculator there, I was looking for the minimum. And the first thing it asks is the left bound. See that little spider thing that you're going to use your left and right cursors? The little spider thing here, I want it just to the left of my minimum. And I hit enter. And then I cursor left and right, get it to the other side of my minimum and hit enter. And then hit enter one more time. And it tells me that my minimum is 1.29 and negative 4.30. So I know that my minimum, my min, is 1.29 and negative 4.30. Okay, then I'm going to look for my max. So to look for my max, I go back to my y equals. I do second trace. I'm in my calc function. Now I'm going to go down to 4 for max. There we go, 4 for max. And I'm going to cursor over so I'm to the left of that maximum value of that vertex. Hit enter. And then I'm going to crest over past to the other side of it, hit enter one more time, and this tells me that my maximum is negative 1.29 and 4.30. So my maximum is negative 1.29 and positive 4.30. And so my x values here, at this one, my x value is negative 1.29. That's at my max. And at my minimum, it's positive 1.29. These are my x values. And so if I'm working on my increasing and decreasing, if you look, it increases from the beginning up to this point, and then it decreases from that point down to the minimum, from the maximum to the minimum, and then it increases again. So we have, it changes a couple of different times on this one, so we have to account for every one of those in our intervals. So for my increasing, it starts at negative infinity and goes up to negative 1.29. Again, you're only looking at the x value because you're going along the x-axis. And it also increases from positive 1.29 and up through positive infinity. My decreasing, I only have one decreasing interval, and it decreases from negative 1.29 to 1.29. And those are my increasing and decreasing variables. So let's try a different one. We're going to try 3x squared minus 6x. I'm going to go back to my calculator, and I'm going to plug in, I'm going to clear my equation out of my y equals, and I'm going to put 3x squared minus 6x, do second trace again, which brings me to my calc menu. I'm going to start with my maximum, so I'm going to do number 3. Okay, sketching out my graph. This is a parabola, so my sketch of my graph is going to look like this. It's going to be here, and it goes down like this and up like that. Okay, so that's, and you're just sketching. All right, and then to find my minimum, I'm going to cursor, so I'm just to the left of the minimum, hit enter, use your left and right arrow and cursor over to the right of it, and then I hit enter, and then I hit enter one more time, and it tells me my minimum is 1 comma negative 3. So my min is at 1 comma negative 3. Well, that's my min. The x value of my min is 1. That's the one I want to pay attention to. And I don't have any other peaks or valleys. So this one starts off decreasing from left to right, and then once it hits this value, my vertex, it increases from left to right. So if I'm writing this out, I have a decreasing interval from negative infinity to 1. You're only looking at the x value, and an increasing interval from that point, that's when it starts and turns to go back up, off to positive infinity. Okay, so that's how we find the increasing and decreasing intervals. Okay, the next thing that we're looking at on functions are end behavior. And when we give the end behavior for each function, we're going to use infinity notation, and we're going to use domain and range. Okay, so I'm going to talk about what it looks like, and then I'm going to talk about what it means. We're going to start with x squared plus 8, so I'm going to go ahead and put that in my graphing calculator. So I'm going to go to y equals, I'm going to clear out what's there, and I'm going to put x squared plus 8, and then I'm going to do second trace, and then we'll just do minimum, we'll just get it sketched on here. Okay, so it's a parabola way above. All right, so we've got a parabola, and it's above the mean. To get my minimum, I'm going to go left of it, hit enter, go to the right, hit enter, and hit enter again. And that minimum is really, really tiny. It's really 0, comma 8. So this is it, 0, comma 8. This number that's like negative 1.15 e, this is a exponential function that basically has 6 decimals to the left. It's like 10 to the negative 6. So basically it's close to 0, so we're just going to call it 0.8. My end behavior, the way I write that is as my x value, so as x approaches negative infinity. So negative infinity is on this side, positive infinities on this side. As your x goes from left to right, or right to left, as it goes towards a negative infinity, okay, so if it goes towards negative infinity, which direction is it going? Is it going up or down? Well, this is going up. So as x approaches negative infinity, the function goes towards positive infinity. So as it goes towards the left, the function goes up. And as your x, as the values go towards positive infinity to the right, my value also goes up. So as it approaches positive infinity, my function, the line, will also go towards positive infinity. And this is called the end behavior. We're looking at quite literally the ends, the arrows of the graph. And what are they doing? And what you're doing is the left side and the right side. The left side is towards positive infinity. The right side's towards, the left side's towards negative infinity. The right side's towards positive infinity. And you're telling me whether it goes up or down on those sides. Okay, my domain is from left to right. Going from left to right, my domain is from negative to positive infinity. Range is from bottom to top. It's at 0, 8, so it doesn't start until 8, and then it goes up towards positive infinity. So this goes from 8 to positive infinity for my range. Okay, let's try one that's got a cube in it. Get all my stuff out of the way there. All right. So I go back into my y equals, I clear out the equation that's in there, and I have x raised to the third power, and then make sure you get out of the power, minus 5x, and second trace min. Okay, and this is where I've got another funky curve, because it's a cube. So this one goes up and down and up, is the way it kind of looks on here. To figure out my minimum, I'm going to go to the left. Remember, I put in minimum, so I'm going to the left of the minimum. I hit enter. I'm cursoring over to the right of the minimum. Hit enter again. And I get 1.29 negative 4.30. Okay, and remember this was positive, or negative 1.29, positive 4.30. Right, but we don't really need those values. That's the max and the min. We'll need those for increasing and decreasing values, but for end behavior, all you have to do is look at the arrows. So for end behavior, you're always going to have as x approaches positive infinity and as x approaches negative infinity. Okay, those two are always going to be true, because you're telling me towards positive infinity, what happens on the right side, towards negative infinity, what happens on the left side. And in this equation, as we go towards positive infinity, the function's going up. So as it goes to the right, my function is going up, positive infinity. But as we go to the left, towards negative infinity, my function is heading down, so it's going to negative infinity. Remember, domain is left to right, so it's negative infinity to positive infinity. Range is bottom to top, and we're going from arrow to arrow, so that's also negative infinity to positive infinity. Okay, so make sure you know what we're looking for. This time we're looking for end behavior. So I just need to get a sketch of it. And I've got y equals, I'm going to clear that out. I have 3x squared minus 6x, second trace, and I hit enter because I just want to see what it looks like. Okay, this is a parabola, and this parabola goes like that, roughly. Okay, so just sketching it. All I'm looking at right now is my end behavior. The two things for end behavior is always as x approaches positive infinity, that's my right side. Remember, positive infinity is over here, negative infinity is over here. And we're going to look as x approaches negative infinity. On the right side, my function's going up. So as it goes to the right, my function goes up, so it goes to positive infinity. As it goes to the left, my function is still going up, so it's still going to positive infinity. Left to right is my domain, so my domain is negative infinity to positive infinity. And then to figure out my range, I've got to know what this point is. So I'm going to come back here and I'm going to go to my y equals. I'm going to hit calc trace. I'm going to find my minimum. Remember, I cursor to the left of the minimum, hit enter. Cursor over to the right of the minimum, hit enter again. And this tells me that that is 1 comma negative 3. I know we did this before, but I feel it's a good exercise to go through the calculator again. So this is 1 comma negative 3. So that means it's down 3. That's your y value. Your range is your y values from bottom to top. So the first thing it hits is negative 3, and it touches it, so it's inclusive with a bracket. And it goes up through positive infinity. And that's how we find end behavior. So we've learned about symmetry, we've learned about increasing and decreasing intervals, and we've learned about end behavior.